Let's implement the binary search tree, the balanced binary search tree, which can contain the duplicates elements. So, the problem here is that if they have binary tree with duplicate elements, they can't construct the balanced binary tree. Because if there are many duplicates, this is impossible. And the idea is to somehow, so we have a list of some elements and the merge the duplicate subsequences into the one elements. Actually, they merge it into the pair. The first element is the element itself, and the second element is tell to us the number of the elements, number of these elements. How many this element repeat in our list. So I need some helper data type. I can call it LM, and it takes some type A. And element can be either the single element of type A or the multiple element of type A, and of course we need to count the counter of this element in the case of multiple constructor. So actually I can do it. I can do this by simple pair type, but here I want to do the special type for this. And of course I want to create a function. I will construction function or build function. I can name it B. It takes some list of orderable A's and return to me the binary tree. So we have this binary tree definition inside this model. And here I want to define the binary tree of some type LM of type A. And here I want to provide the implementation of this function. So let's run CI and load our file. You can see it loaded, but of course they need to do the implementation. And as always, we can start from the simplest case. If I have empty list, I need to return the empty tree. But otherwise, if I have not empty, some not empty list, how can I define this function? Of course, I think I need some helper here. This helper will take the already ordered list of my elements, but here I have no guarantee what I will receive the ordered list, and That's why I need to, at first step, I need to map each element of this list to a LM type, and also I need to sort all the elements in this list. And I think it will be helpful if I make my LM an instance of ord. So I need to make my LM of type A an instance of ord, and I think I must have the A must be in ord class to do this. And here I need to do the definition of this type class. Actually, I do the proxy into the A type. So let's look at into ord type class, and we can see here we need to the minimal definition. I need to define compare or less or equal function, and let's define our less or equal function. Okay, if they have single A and single A, this function is equal to, we can proxy it like this, I think. Okay. And of course I need to define all the possible cases here of my constructor. I can have single A and LM A. LMB, sorry. And this is not matter. How many elements I want to just compare the inner type. So let's go through other cases. If they have two LMs, in this case they also do the same thing. And we need some mirror cases here, like these. So we have single LM, LM single, and LM. Yes, and I think this is all possible combinations. Let's try to check this implementation. Incorrect indentation. So let's comment this. I want to check my, of course here not LM, we want to use multiple constructor. And of course I want to also add EQA here. So I think I need to have braces here. So it tells me that I need also EQ class for my LM here, and let's do it. I think like this. They need to run all the cases. Yes, it compiled, and now I have so now I can compare my LMs, and I can do ordering on the LMs. For example, if I have single one, and I can check if it equal to multiple one. You can see this is the same one, but the elements are equal. And of course I can check for less or greater how the elements compare each with other. Okay, now I think I want to add a show here, derive show. I don't know, maybe there is a very short way to derive also equality and ord type classes for this LM, new LM type. If you know how to do this, please write in the comments. I think this is possible, but here I do this simple implementation, and now we can go to definition of our build balanced tree with duplicate elements. Okay, let's write this comment: build a balanced BST with duplicate elements. So what I need to do at first I have this list of elements of type A. I can compare these elements, and that's why I can sort this list at first step, and then I can make a groups on this sorted list for these elements. When I want to transfer these groups to my LM type, so at this step I will reduce the memory usage. If I have many duplicate elements, I will reduce all such elements only to this type, which actually contain a pair of the element value itself and number of how many times it repeated. Okay. So what we have for sort? For sort, I think we have this function. There is no this function. Sorted. So I think I need to load list module, data list, reload, and look at sort function. Yes, and also I need group function. Yes. So you can see what if I have the sorted list. I can use my group function to make groups on this list. And then I can map such this group to my data type lm. So what if I have some not empty list here? Of course, I will have this some helper here, the go function, which takes some list xs. Let's say the ys, ys, sorry, ys. And here I need to define this ys. And how I do it? I will run my apply my sort function to my initial list. I will receive this list, and then I want to group this list. After that, after I have this grouping list, I want to fmap it to lm type. Okay, I can use fmap here, and I think I need some lambda function here, which take this list and transfer it to. So I need some case here. If the length of this list is equal to 1, then I will create the single element with head of L. Okay. And otherwise, I will create the multiple element of head of L. So I will pick up some nomad element, and also I need to provide the length of the list. Okay. So this function will transfer me. Actually, I can define type signature of this function here. It takes list of A, and it produce a list of lm of A. Sorry, of course it takes a list of A's and produce a list of lms. So with this lm type, they do the merging our lists, group lists. Okay, this line too long, and I think I need to do, let's remove this function. I will call this function m as mutate, and I define it like this, like lambda function. Okay, after that, I hope I don't do any errors here. After that, we have these y's, so the list of our lms, and they can work in our go function with this list of elements as they have no repeated elements at all. Okay, I think I don't need this lambda here. I can remove it. I can define it like this. And I think for readability, or make it more readable, I can do it like this. Like this. Yes, I think it's more readable. The next thing, we can go to our go definition, go function, which takes some list of y's. So let's sketch the empty case here and remove it from here. And of course here I think I need to, so what I need to do here, here I think I need to, how can I build a balanced binary search tree if I have no duplicates? So wise lists have no duplicates now. Of course, I can do it very simple. If I take the median of this list and create a node with this median, and then I will take the left part of the median and the right part from the median, and the recursion I can build left and right subtrees, and that's all. That's all the solution. So I can write it this like this, I think. So I will create node with my median element, and from the left I will run, the left subtree I can define like in terms of go function itself, but I need left elements from the median, and from the right I need right elements of the median. Okay. And of course I need to do definitions here. So I need to define median. Yes, I need to define median. and I need to define left elements from the median and right elements from the median, and actually I can do it with so actually I have a splitted function which split the list at some index, and I can use this function here, and I want to split my list at some median index, and if I split it I will receive the pair which I can pattern match. I can have the left side of the median and the right side of the median, and the right side I can also pattern match like this to get my median. And I think that's all. All I need to define here is my median index, and it's defined like length of the whole list divided by 2. Yes. So in such a way I think I can build the balanced tree which contain duplicate elements. Okay, let's try to compile this. I think errors, it will have errors, of course. Oh. So I need to do this. Okay, let's do a little bit different naming here. I will add this sign here. I don't want this clash. Let's try to reload. Yes, so the problem here is that in type signature I write this as a parameter, but here I don't want to use it. I have it in my namespace. So I think it's better to remove it from here because it leads me to for all in type signature. I want to skip this. Here I have not enough arguments to split that function. Let's look at this function again. Of course I need to provide the list which I want to split and the done. So I've called it's compiled. And now let's try to build some tree. 1, 2, 3, 4, 5, and let's print it. So as you can see, they have this tree. The problem is balanced it or not. Let's add some more elements. I think it's look like balanced. But what if I have multiple ones here? As you can see, the structure of this tree stays the same, but here I have this counter which counts me the number of elements. And this data is represented with mult data constructor. But let's look again at our first run. Is this balanced? Yes, I think it's balanced. At the root it have the height here 2 and here 2. We have 0. The left and minus right some branch height, so it's balanced. Let's create some more complex case. For example, if I have several 5s, and what if I have 10 here? Of course, I can provide not ordered list because we do the sorting. Let's check this thing. For example, if I have minus 100 and minus 200, and what if I have minus 100 here and 1 from here, or 7 from here, like this. So what do we have? We must have two 100, minus 100, yes, we have it. They have single 200s, and they have 7 2 7s. Okay, and they have 4 1s. So as you can see, this works. This algorithm works. It allows us to construct a balanced binary search tree with duplicate elements. So, and it is very simple. Here we just do the splitting from the median, and because from the left of the median we have sorted a list of elements, and because from the left all the elements is less than our median, and from the right all the greater or equal. So there is no equal. If there was equal elements, we can broke our constraint by based binary search tree constraint. Here we have all our elements actually have some uniqueness because all the duplicates information contains in the second argument of our multiple constructor. But the sorting here provides to us that the build the tree, because on every step put the same number of elements to the left and to the right, and all the elements from the left is lesser and all the elements from the right is greater, and they do this for every node. And that's why in the end they have a balance in this tree.